Morning. Welcome to another episode of Sir J Maths, where we try to make maths as simple as possible. Now, this morning we'll be looking at a topic called the cosine rule. Now, if you are going to do trigonometry as a subject or as a topic in mathematics, then you have to know about the cosine rule. Now, the cosine rule simply is a rule that basically is used to solve either for a side of a non-right angle triangle or an angle in a non-right angle triangle. Now you would have known that, okay, this is an example of a right angle triangle in which once you see a little rectangle here, it indicates that it is a right angle triangle, and then the side opposite the right angle would be called a hypotenuse. And the hypotenuse is the longest side of the right angle triangle, because the longest side is always opposite to the largest angle. And so if the largest angle in the right angle triangle is 90 degrees, so the side opposite to it is referred to as a hypotenuse. Now if we come over here, and when we look, this is triangle ABC. Now in triangle ABC, if this is the vertex B here, the angle is inside here, and so the side opposite to this angle is the side little b, which we also refer to as AC. Now little c is opposite to angle C, and little a is opposite to angle A. Now what if we want to find, say, side A? What if we don't know side A? Now, if we want to find side A, which is for a non-right angle triangle, because clearly, as you can see, this doesn't appear as if it is a right angle triangle. So assuming it is not a right angle triangle, and we want to find side A. Now, to find side A, we have to know what angle A is, because side A is opposite to angle A. Now, what we also need to know, the two sides that actually borders angle A, and these two sides are C and B. Now using the cos rule, basically if we want to find side A, we write the side that we want to find, the square on that side equals to the sum of the squares of the two sides bordering this angle here. And these two sides are b, so we write b squared plus c squared, and then we subtract 2 times the product of the two sides. So it's minus 2bc times the cosine of the angle A. So times the cosine of angle A. And this is a cos rule. Now by extension, if we want to find side B, so what you notice here, okay, side B is what we want to find, so it's a square on B, square on the side that you want to find, which would equal to the sum of the squares of the other two sides. What are the other two sides? A and C. So it would be A squared plus C squared minus 2 times the product of these two sides, that is A and C. So it's 2 times AC times the cosine of the angle opposite to the side that we want to find, and this angle clearly is B, so times cosine of B. Now if we go further, if we want to find side C, so then that C squared equals, finding side C, we have to know the two other sides. So the two other sides would have been A squared plus B squared minus 2 times the product of these two sides, which are A and B, times the cosine of the angle that is opposite to the side. So the angle opposite to side C here is actually angle C, times the cosine of angle C. Now, let us do an example. Let us say we have this side, this triangle ABC. So here I have A, B, C. Okay, we have angle A being, say, 60 degrees. We have this side being, say, 10 centimeters, this side being, say, 12 centimeters. And the question says, find length BC. Now find length BC. So right here is BC. This is what we want to find. So clearly this side is opposite to angle A. So right here we know that what we are finding is side letter A. So A is what I don't know. So let us come up here now and look at this in terms of this. So if this is A, this is B, this is C. So using the cos rule, because again it is not right angle triangle, so hence we are not going to use whether trig ratios or Pythagoras' theorem. So then finding length BC, we just realized that okay, we have two sides and the included angle. So in order for you to use a cosine rule, right, one criterion is that you must have two sides and the angle between. So everything that we did up here, clearly for us to know or to find A, we must know two sides and the included angle or the angle between those two sides. And so this is what is given. So as soon as you look at this question, find length BC, you realize, okay, I have two sides here and the angle between. So the angle between here is this angle. So I'm going to use a relationship with A. So then I write A squared equals B squared plus C squared minus 2 times the product of these 2BC times the cosine of A, of the angle A. So now what we are going to do here is to substitute the values of B and C into the equation. So anywhere we see B, we are going to put 10, and anywhere we see C, we are going to put 12. So then it is 10 squared. You can leave out the unit for the time being. So it's 10 squared plus 12 squared minus 2BC. It's best to put 2BC, which is 2 times B times C, in a pair of brackets so you don't make any mistake right here, because you are supposed to multiply before you subtract. So it is 2 times 10 times 12, right, times the cosine of A. So that's cosine of A, but A here is 60 degrees. So what we have here is A squared equals 10 squared is 100, 12 squared is 144, and to square a number means to multiply the number by itself, minus, in bracket, 2 times 10 times 12, we can say 2 times 1 is 2, 2 times 12 is 24, and then we join the 0 using the 0 trick, so we have 240 times cosine of 60 degrees. Now cos 60 degrees, now 60 degrees is found in the first quadrant. This is what you call the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant of the unit circle. So the first quadrant basically lies from, say, 0 degrees to 90 degrees. Second, between 90 and 180. Third, between 180 and 270. And the fourth, between 270 and 360 degrees right here. Now, in the first quadrant, all ratios are positive. So you need to remember that. All ratios are positive. Now, and so if you find the cos, the sine, and the tan of an angle in the first quadrant, it is supposed to be positive. Now, except for, say, the tan of 90 degrees, which you are not able to find. Now, the cos of 60 degrees will give us a positive ratio, and that ratio is a half. Expressed as a decimal will give us 0.5. So you could just take your calculator, and on the degree mode, you press, make sure you press cos, ensure that it is on the cos mode, and then you press 60 degrees, then equal and you'll see 0.5. So 0.5 here is a ratio. Now, what is also important is that we may meet upon angles that are greater than 90 degrees, dealing with cosine. Now, greater than 90 degrees would fall in the second quadrant. Now, what you need to remember is that, okay, in the second quadrant, cosine is negative. So the ratio that you are going to get must be negative once the angle passes 90 degrees up to 180. That is, if you get an obtuse angle. So once the angle is obtuse and you are finding the cosine of it, then the ratio has to be negative. So remember, with the cosine rule, in the first quadrant, between 0 and 90 degrees, then the ratio is positive. Between 90 and 180, which is an obtuse angle, the ratio must be negative. So just remember that. Now what we have now is a squared equals, now we are going to add 100 to 144, we get 244 minus 0.5 is a half. Half of 240 is actually 120. Now when we take 120 from 244, 0 from 4 is 4, 2 from 4 is 2, 1 from 2 is 1. So a squared equals 124. Now what we want to find is a. Now a is squared here. In order to get rid of the square, finding a, simply we need to find the square root. And so when we find the square root of a squared, we are going to be left with a. Now whatever we do to one side must be done to the other side. So we are going to find the square root of 124. Now it is of note that the square root of 124 can either be the positive root or the negative root. But because we are doing length, we are finding length. Length cannot be negative. So we are just going to stick to the principal square root, which is positive. So a here equals. Now you are going to take your calculator and find the square root of 124. Now, because if 11 times 11 is 121 and 12 times 12 is 144, so clearly when you find the square root of 124, it must lie between 11 and 12, because 11 times 11 is 121. So when you find the square root of 124, you get 11.1355 something. Now let us say we want to round it off to one decimal place, the 11.1 centimeters. Now you need to have the unit because it is length. So the length here, the units are in centimeters. So a here equal 11.1 centimeters. And I can put correct to one decimal place, which is also correct to three significant figures. Now we set out to find length BC. But length BC is the same thing as side A. So basically you could say, therefore, BC equals 11.1 centimeters, correct to one decimal place. Okay, now let us call this example 2. Here, the question is calculate the length of YZ, correct to one decimal place. Now as you see this triangle, you realize that it is not a right angle triangle. You get two sides and the angle between. So therefore, in order for you to calculate YZ, which is the third side, you are going to use the cosine rule. So clearly, the cosine rule will have to be used here. So YZ, what exactly is YZ? YZ is little x, because it is opposite to angle x right here. So x or little x is what we don't know. So following up on what we did before, because you don't have to use a, b, and c, little x, using the cosine rule, the square on the side that you want to find equals to the sum of the squares of the other two sides. So this is angle y, or right here is angle y, so over here is little y. So this must be capitalized. Now this is big Z, over here is little z. And so x squared equals y squared plus z squared minus, following what we did before, 2 times the product of these, yz, times the cosine of the angle that is opposite to the side that we want to find, and that is cos of x. So whatever letter we start with, we must end with that same letter, but it must be the capital letter, because a capital letter denotes the angle, and a common case letter determines or denotes the side. So then it is x squared equal y. Now we do the substitution. What is y? Now, y here is 25. So again, we can leave out the unit, 25 squared plus z, which is 32. So it is 32 squared minus, now again we put this in a pair of brackets, 2 times 25 times 32 times the cosine of x. Now this is 135 degrees. Okay, now x squared equals, now 25 squared is 25 times 25. And 25 times 25 on your calculator will actually give us 625. So this is 625. But then if you want to know what 25 squared is without the calculator, we know that any number that ends with 5, the square of that number must end with 25, because here you realize that 5 squared is 5 times 5, which is 25. So if it is 25 squared, we know that it must end with 25. So the digit before the 5, or sometimes it can be 2 digits, you simply multiply that digit by a number that is 1 more than that digit. So 1 more than 2 is 3, so 2 3s is 6, and we actually get 625. So this is 625 plus 32 squared. Now 32 squared is 32 times 32, or if you have a square button, you simply press square. So what we get here is 1024 minus 2 times 25 times 32. Now 2 times 25 is 50. 50 times 32 is 50 times 32. We get 1600 times the cosine of 135 degrees. Now when you look, you say 135 degrees. But remember, we had been looking at the unit circle in terms of the angles. So remember that this is 0 degrees, this is 90 degrees, this is 180 degrees. So where do I find 135 degrees? 135 degrees is actually found in the second quadrant. So 135 degrees is, say, 90, 45, 135 is somewhere here. So this is an angle, which is an obtuse angle. And the obtuse angle, the cosine of an obtuse angle must have a negative ratio. So we know that cosine of 135 degrees must have a negative ratio. So we find cos of 135 equals, and as you can see, you get a negative value. So it is negative 0.707, and usually for a certain level of accuracy we can use correct to about 3 decimal places. So it's times negative 0.707. Now x squared here equals, now we add 625 to 1024 plus 1024, and you could get your calculator and check in the meanwhile. Then you press equal. What we have here is 1649. Now minus. Now right here you have to be very careful. The reason you have to be very careful is that don't add 1649 minus 1600. And that is why I ask you to put this in a pair of brackets, because you may be tempted to subtract 1600 from this. But when you put it in brackets, you know that you have to apply the Bumdas principle. That is, you do brackets before you do anything else. And so it's 1649 minus, now we are going to work out this. Now 1600 times negative 0.707. When we multiply two quantities with different signs, the result has to be negative. So clearly we must get a negative here. And you can just use a calculator and you multiply 1600 times, say, 0.707, because we already determined that our answer here must be negative. And then you press equal, and what you have here is 1131 0.2. And then we close our bracket. Now, here now we need to simplify. So right here it's x squared equals. Now, here we need to remove the bracket. Now, a minus sign on the outside will change the signs of all signs on the inside. So if the sign here is negative, clearly when we remove the bracket, it is going to be positive. If this were positive, then our answer will be a negative. So right here, when I remove this bracket, the negative sign here will change the sign on the inside. So I have 1649 plus 1131.2. Then I go to my calculator and I add 1131.2 plus 1649, and I get, so I have x squared equals 2780.2. Now what exactly do we want? Is it x squared? No, it is actually x. So we are going to find the square root. So we find the square root here. Again, we find the square root of 2780.2. But if you remember, we need to find just the principal square root. So we don't have to put positive or negative because it is length. So we are just going to take the principal square root, which is a positive one. So then we now go ahead and find the square root. So it is square root of 2780.2. And what we get here is 52.7 something. Now, on my calculator, I have 52.727. I want to give it to one decimal place. So if it is one decimal place, only one digit I want after the decimal point. So here I have 7, then a 2. Now, the 2 after the 7 will not affect the 7 because the digit has to be 5 or more for it to affect the digit in the tens position here. So it's 52.7 centimeters correct to one decimal place because it is not equal to 52.7 because it is an approximation. And so we have to state that, okay, correct to one decimal place. So therefore, since we set out to find yz, which is the same thing as x, but fixing it out, we can write, therefore, yz equals 52.7 centimeters correct to one decimal place. Okay, so far we have looked at two questions in which we were required to find basically the length of a side of the triangle. But what if we know all three sides of the triangle? Then what do we do? Now, to use a cosine rule based on what we have seen so far is okay to use a cosine rule if we simply have ABC and we know this side and we know this side. So let us say we know this, we know. In order to find, so we know two sides, we don't know the third side. In order to use a cosine rule, we must know the angle that comes between the two sides, or which we call the included angle. So it's like we would have side, angle, side, side, angle, side. So we basically know the side, the angle, and the side, which these two sides we know, and the angle between. So as we saw, we can use a cos rule. Now, in this case, we now have three sides. Now, once you have three sides, we can also use a cosine rule to find any angle that is in the triangle. Now, there are 6 elements of a triangle. 6 elements. 3 sides and 3 angles. So if we want to find one of the angles, we would have already know 3 elements, so we need to find a 4th element right here. So again, the cosine rule can be used. Now let us go to the question. Calculate the size of angle DEF below in triangle DEF. Angle DEF. Alright? Now, alright, let me just change this a little bit and put angle EDF instead. Angle EDF below in triangle DEF. So it's angle EDF. So this is the angle that we want. So this angle, I can put a question mark right here. I want to find that angle. Now let us examine something. This angle D is opposite to this side or this length, EF, which is 8 millimeters. Now EF is the same thing as little d. So I can write little d equals 8 millimeters. Now, there is a rule that you need to remember or need to know as it relates to geometry. Now, if you get, say, 3 sticks, one being, say, 5 feet long, another, say, being 3 feet long, and another, say, 10 feet long, there is no way that you can actually put all 3 sticks together to form a triangle. Why? If this is 10 feet, assuming that this is the longest, this being 5 and this being 3, there is no way that you can arrange them or put them together so that you have a triangle forming. Why? Because a triangle must satisfy certain criteria. One such criterion is that the length of any 2 sides, or the sum of the length of any 2 sides, must exceed the third side. So 3 plus 5 is actually 8, but this is 10. So this is not possible because the sum of any 2 sides must be greater than the length of the third side. So clearly, it could never form a triangle. And so when we come here, this is 8 millimeters. Another rule is that the longest side is always opposite to the largest angle. So if I want to find this angle, clearly this angle is opposite to the longest side. So this angle will be the biggest angle in my triangle. And this is 4 millimeters. This angle here will be the smallest angle because it is opposite to the smallest side. So there are certain things that you have to know when you are doing this particular question. And so we set out with the formula. Now, since we want to find angle D, well, usually if we are finding the side D, it would be D squared. So we set out D squared equals, now E squared plus F squared. So remember, that's what we basically do. We find the sum of the squares of the 2 other sides, right? Minus 2 times the product of these, EF, times the cosine of the angle that is opposite to the side. So that is angle D. So remember, any letter that you start out with, you must end with it, but it is a capital letter over there. Now, it is of note that this triangle basically satisfies the rule that I mentioned, in which the sum of any 2 sides must be greater than the length of the third side. So when I add 5 and 4, I get 9. 9 is greater than 8. When I add 8 and 5, it is greater than 4. And when I add 8 and 4, it is greater than 5. So this triangle basically satisfies the rule. Now, but when we check here, D, we already have D. So clearly it is not D that we want to find, but we just set out with this relationship. What we actually want to find is D, which is the angle. But D is cos D. It is really cos D that I have here. That is multiplied to negative 2F. Now, if I want cos D to basically be the subject of the formula, because this is like an equation, which is an equation in which D squared is a subject. But what if I want, say, cos D to be the subject? What I could basically do is to transfer all of this over here to the other side of the equation, or this is minus 2EF cos D. I could add 2EF cos D to get rid of this. But if I add it over this side, I would add it over this side as well. But what I'm doing, I'm simply taking this over to the other side. The sign will basically change because I don't want to work with the negative. So I will get 2EF cos D equals, now what was already over here is E squared plus F squared. But when I take this over to this side, now I'll take it over, and D squared was already over here, but I don't want a D squared over here. So what I could do, I could subtract D squared from this side. But if I subtract it from this side, I'll have to subtract it from that side. Or I could simply take this over to that side. And when I take a quantity over to the other side of the equation, its sign will change. So it is positive D squared. So it goes across as minus D squared. So now what do I have? I have 2EF cos D equals E squared plus F squared minus D squared. But remember, what I want cos D to become the subject of the formula. So since this is cos D is multiplied to 2EF, to get rid of the 2EF, I can do the inverse operation, which is to divide. So I divide here by 2EF. So divide here by 2EF, that gone. So I'll have to do it to do the same thing on the other side. So I'll divide that by 2EF. So what I have is cos D equals E squared plus F squared minus D squared over 2EF. Now, so cos D equals, now we are going to do the substitution. Where I see E, F, and D, I basically put in these values. So E is 4, so it is 4 squared, plus F is 5, so it's 5 squared, minus D is actually 8 squared, all over 2 times E times F, which is 2 times 4 times 5. So I have cos D equals 4 squared is 16 plus 5 squared is 25 minus 8 squared is 64 all over 2 5s 10, 10 4s is 40, or I could say 2 4s 8, 8 5s is 40. So no matter the order in which we multiply, we will get the same product. That's the commutative law. So what I have is cos D equals 16 plus 25 will give me 41 minus 64 all over 40. So cos D equals, now 41 minus 64. Here I have 41. The minus in front means I owe 64. So if I pay what I have, I am going to still owe because I owe more than what I have. So 1 from 4 is 3, 4 from 6 is 2, so that's negative 23 over 40. So then I have cos D equals, now I am going to divide negative 23 by 40. So negative 23 divided by 40, I actually get a terminating decimal, which is an exact decimal, as in cos D equals negative 0.575. So this is a terminating decimal in that it ends at 5 right here. So it is exact. Now, if it wasn't a terminating decimal, it is best to give your answer here for the ratio correct to 3 decimal places. At least 3 will give it, make it be more accurate. Now, if you go to your calculator, you say cos, and above that, you say cos to the negative 1. So this is cos inverse. This is cos. Now, if we want to find the ratio in cosine, whose angle is 60 degrees, you'd press cos 60 degrees. And as we saw before, you'd actually get 0.5. So the cos 60 degrees equals 0.5. What that is suggesting is that, okay, we know that cos equals to the adjacent over hypotenuse. So if this is 60 degrees, right, and this is a right angle triangle, this basically here is the adjacent side, and this is the hypotenuse side. So cos 60 degrees being a half is like, okay, this is 1 and that is 2. So cos 60 degrees is a half, adjacent side over the hypotenuse. Okay? But what if we got the ratio being 0.5 and we want to find back the angle? So what we'll have is, we'll have to now press or access cos inverse, because this gives us a ratio while this gives us the angle. So you'll have to press cos inverse of the ratio to now get the angle. So you'd have to go on your calculator, access the inverse button or the inverse for cos, and then you put in your ratio in order to get the angle. So normally to access, you have to press cos inverse, then 0.5. So shift the cos inverse, then the 0.5, and then you press equal and you get the 60 degrees. So backtrack to down here, or fast forward to down here now. Now this is cos d equals negative 0.575. So what we actually want is d. So the cos of which angle would give us negative 0.575. Now, if we remember that if it is cosine and the ratio is negative, then the angle must be obtuse. And if the angle is obtuse, then it is greater than 90 but less than 180 degrees, in that the angle is found in the second quadrant, based on what we did before. So we know that this angle has to be greater than 90 degrees but less than 180 degrees. So we are going to take d, we want to find d, so it is a cos inverse, because it is an angle now whose ratio is negative 0.575. And so d equals, and we go on our calculator and we press shift cosine of negative, ensure that you press a negative, 0.575 equals, and what we have here is 125.099. So giving it to one decimal place, it is 125 point. Okay, now try these questions. Here you're asked to find the missing sides. Here you're asked to find the required angle. And as you can see, you're going to use the cosine rule. Now, stay tuned for more lessons. I want to encourage you to subscribe, tell people about this channel, and encourage them to subscribe as well. Thank you very much.